Okay, so we're looking for second derivative. So the first derivative is a product rule. Okay, the derivative of the first one is power rule, chain rule. Derivative of the inside is a 1, yay. Derivative of this is 1. Crisscross. My first derivative will be this times this plus this times this. And now, instead of multiplying all that junk out, the key is factor. Okay? So I'm going to factor out an x minus 2 that they have in common, but they actually have 2 of them in common. So I'm going to factor out an x minus 2 squared, and what's left over? If I take an x minus 2 squared out of this first group, then I have 1 left over. If I take out the x minus 2 squared from the second group, I'm left with a 3 and an x minus 1. Now just distribute and combine like terms. And you have, let's see, x minus 2 plus 3x minus 3. Combine like terms, and that's my first derivative. What is that, 4x minus 5? That is your first derivative. Unfortunately, you are not done because you pretty much have to do all that same work again for the second derivative. Okay, so that's the first derivative. Now we're going to find the second derivative, which just means derivative of that. And it's another product rule. How fun. So x minus 2 squared and a 4x minus 5. Derivative of this is 2 times x minus 2. Derivative of that is a 4. Crisscross. So I have 4x minus 2 squared plus 2x minus 2 times 4x minus 5. Again, you could FOIL and everything and combine like terms, but it's usually easier to factor. So you can factor out a 2 from both if you want to, or leave it. That won't really matter. I'll take out a 2, and they both have an x minus 2 in common. What's left over? If I take a 2 away from this 4, I still have 2 left. And if I take one of those, I still have 1 left. In the second group, I take away the 2 and the x minus 2, and I'm left with 4x minus 5. And I don't really need those parentheses. Now just distribute and combine like terms. So I get 2x minus 4 plus 4x minus 5. One more thing. What is that, 6x minus 9? Okay, now here's the thing. That is my second derivative, and it works just fine. But that's probably not the second derivative that they have in the back of the book or on the answer sheet. And here's why. Since they didn't just ask what is the second derivative, I can write it any way I want. What they really asked is for the inflection points and the increasing and decreasing. We're going to get the same answer whether I leave my answer this way or not. But why won't my answer match theirs? That would be because, can you see you can factor a 3 out of that? So if I took a 3 out of here, then that 3 would come out here with this 2 and make it a 6 out front. So they would probably have a 6, x minus 2. And again, if I took a 3 out of here, then I'm left with a 2x minus 3. That's probably how they wrote their second derivative. It won't matter, though, because the next step is to set each factor equal to 0. And we're both going to get x equals 2 and x equals 3 halves, whether you do it this way or that way. Okay? And then you do your second derivative sign chart from there. I know you know how to do that.